Okay, last two problems, 21 and 31. 21, hauling in a dinghy. We got this little picture here. I'll try to draw it real quick. We got a boat. We got this little stand over here. We got that. And then we got this little distance here. That distance is 6. So we got a dinghy is pulled toward a dock by a rope from the bow through a ring on the dock 6 feet above the bow. The rope is hauled in. So let's just call that X. So the rope is hauled in at a rate of, where is it? Rope is hauled at 2 feet per second. And I'm going to call that negative. And the reason I'm going to call it negative is because X is getting smaller. Okay, getting smaller, not because it's moving right or left, just because X is getting smaller. And then at what rate, how fast is the boat approaching the dock? So the first question, we got two questions actually. So A is find dx dt. How fast is the boat approaching the dock when 10 feet of rope is out? So when x equals 10. And then the second problem is at what rate is the angle changing? So the angle is way up here at theta. So we'll call it d theta dt, find d theta dt at that same time. So we've got a couple possibilities here. This is a little bit different, right? Because you have the dx dt and d theta dt. Hang on a second. How fast is the boat approaching the dock? The rope is hauled in. Oh, sorry. Whoa, I made a big mistake here. All right, so let's backtrack just a bit. Not a huge mistake, but I called this x, right? And dx dt was 2. The question was how fast is the boat approaching the dock? So I'm going to call that y, so that would actually be dy dt. But you caught that, I hope, right, as I was doing that. So the first equation, pretty simple, Pythagorean theorem again. So A, we're just going to go 6 squared plus y squared equals x squared. Take the derivative, 0 to y, dy dt equals 2x, dx dt. So we cancel out those 2's again. So here's my picture at that instant now when we freeze it, right? So when x is 10, so this is 10, this is 6, which means that has to be 8. So 8 times dy dt, which is what I'm looking for, equals x, which is my 10, times dx dt, which is that -2. The negative's not really become important in this problem so much. We just do a little algebra. We get dy dt equals -20 over 8, or -10 fourths or negative. Whoa, gosh, sorry about that. Or if we reduce that, -5 over 2 feet per second. Again, we'll check that one, 21a. Make sure we're good. Guess I could have checked these before, huh? 2.5 feet per second. Cool. And now part B, a little different, because now I got a little different formula. So all these Pythagorean theorems are now gone. We got this theta. So what I need to do is relate theta with either x or y and 6, some combination of those two. Doesn't matter which ones. At this point, it's at the same moment. So I have dx dt, I have dy dt. So it doesn't really matter which one you pick. You just got to pick the right, proper trig function. So you could pick x or y or 6. So you could pick any of them. Really, you can't go wrong here. I'm going to go, I don't know, tangent, I guess. So I'm going to go tangent of theta equals opposite over adjacent, which would be y over 6. I like to use the 6 just because it's constant. You could use the y and the x, but it's going to cause you a little bit more trouble in the derivative. That's all, because then you have two variables, so you're going to do the quotient rule. So we take the derivative, secant squared theta d theta dt equals 1/6 dy dt. So it's at that same instant. So we're trying to find d theta dt. So now we want secant squared of theta is what we need. So we have a little choice here. We could find theta, but we don't need to find theta because notice we have this little triangle that's 6, 8, and 10, and there's my theta. So secant of theta. Secant is the reciprocal of cosine. Cosine is adjacent over hypotenuse. This will be hypotenuse over adjacent, which means it's going to be 10 over 6. Or reduced to 5 over 3. So that's my secant theta. So if I just go 5 over 3 squared times d theta dt, which is what I'm looking for, equals 1/6 times my dy dt, which was the answer from that last problem, which was -5/2. Now it's just an algebra problem. D theta dt equals, we'll go -5/12 times, I guess if I'm going to come over here, we're going to go 3/5 squared. So I'm just going to take out my calculator. I know I could simplify this, but we're going to go 9 divided by 25 times 5 divided by 12, and we're going to get 0.15. Now this isn't angle changing, so this is going to be radians, not degrees. It always warns out in radians because radians are arc length. So radians have a length attached to them, whereas degrees don't. So again, we're going to check that one. Hope we did good. 21b. 21b is -3/20, which we're going to hope is the same. 3 divided by 20 is 0.15. We're good. All right, cool. Last one, problem number 31. We got a moving race car. We got this little picture here. Let me draw it. So we got a car here. Sorry for my bad picture. I can't draw cars. This is 132 feet, and there's a camera up here. And then there's this angle theta. And 31 says, you're videotaping a race from a stand 132 feet from the track, already drawn in, following a car that is moving at 180 miles per hour. So we're going to call this x. So we know that dx dt is 264, sorry. Let me clean that up. 264 feet per second. They're making the numbers nice. Actually, it makes it look worse, but they're actually going to be kind of nice. You're going to see that in a little bit. How fast will your camera angle be changing when the car is right in front of you? So we're finding d theta dt when car is right in front. So I guess that means x is 0, right? If the car is right in front of us. And then also a half second later, which means if it's half a second, remember the car is traveling at 264 feet per second. So it's going to be x is 132 because it's going to go for half a second. That 132 is pretty nice because of the other 132. So again, we need an equation. This time I don't have that information right there. So I don't have a choice. I must use tangent. Tangent of theta is x over 132. Tangent of theta equals x over 132. We take our derivative. Secant squared theta equals 1 over 132 dx dt. Whoa, I lost a, here, let me rewrite that. You guys caught that too, right? Never want to forget that chain rule. D theta dt equals 1 over 132 dx dt. So now we have two different things. So if theta is 0, that's that first problem, right? So for part A, or not, it's not part A, but for the first part, x is 0, theta is 0, the angle is 0, which means secant is the reciprocal of cosine, right? The cosine at 0 is 1. So this becomes a d theta dt, because that's a 1, equals 1 over 100 times dx dt, which is 264. So 2, this is an angle, radians per second. The second part is 132, is a half second later. So now here's our little picture, just so you see it. Looks like this. This is 132. This is 132. There's my angle. So same equation, right? So this time we want the secant of theta. This is just a 45, 45, 90 triangle, right? So secant is reciprocal cosine, so we're at 45. Cosine of 45 is root 2 over 2. So this secant squared of the secant of theta would be 2 over root 2. We're going to square that times d theta dt at that same instant. So this is still 2 over here now, right? And now I just got to do the 2 squared is 4 over 2 is 2. So it looks like d theta dt equals 1 radian per second. Check my work there on 31, and hopefully I'm right, and we'll be done. If I'm not right, I guess I'm going to backtrack. 31, let's see, the first part, if I can find it here, is 2 radians per second, and the second one is 1 radian per second. So we're all good. That's some basic ones. The ones next set will probably get a little tiny bit harder. These were all sort of similar with some little twists. Hope that helped a little bit.